Hello, everyone. My name is Lisa Schaefer. I want to welcome you to our fourth and final module of the Fall 2024 Stormwater Management Design Review course. So as Peter said, we are recording this session and we hope to post them in the very near future onto the main training page so that you can refer back to them along with your handouts. So they can be a ready reference. Now, speaking of which, if you have not already downloaded the course materials, I will have that link on the next slide. So today we will first examine the GI fact sheet to better understand what constitutes green infrastructure. Then we'll provide two GI example plan reviews, which will tie together the material we had covered in our previous modules. Plus, we'll have another example from Chang'e, and then after that will be our fourth and final quiz. Once we review the quiz, we'll end up the day with an overview of our MS4 program, along with the updates that have been made to the BMP manual and the Stormwater website. Plus, comes next. So here at the bottom of the slide is the link, of course, if you haven't downloaded the materials. And of course, you can always email questions if you think of them later on. Please use the DWQ email account so that everyone in the unit can assist in answering your questions. So once more, we have a rather tight schedule today, so to better respond to as many questions as possible, please type your questions into the chat and the moderator will do his best to get to them. Now, if time permits, at the end of the presentations, we should be able to take a question or two, depending on the time. And of course, we're always open for emails. So once more, if you missed the announcement, we are recording this presentation. So please do not leave the training today until the announcement is made to dismiss you. Teams tells us when you leave. And of course, we want you to be marked as having successfully completed the training. So in earlier modules, my colleagues introduced what we mean by green infrastructure and some of the regulatory requirements pertaining to it. Today, I'll start with a review of the GI fact sheet that we have provided to help you better understand the rule requirements and how designs should meet those requirements and what to check for in your reviews. So then, of course, I'll have an example that incorporates GI into the design, and I'll evaluate whether or not it follows what is spelled out in the fact sheet. All right, so let's start with the fact sheet. So first of all, it's a metric to help you evaluate if a proposed BMP can be used where the rules require green infrastructure be implemented. Okay, so before we go any further, we need to answer the questions that are shown on the screen. All right, so to get right to the first question, we covered in Module 1 what we mean by green infrastructure, which we abbreviate as GI. Now, Dr. McGee also spoke about GI MTDs in Module 2. Module 3 also included references to GI. So to reiterate, a GI BMP is a stormwater management measure that manages stormwater close to its source by 1, treating stormwater runoff through infiltration into the subsoil, 2, treating stormwater runoff through filtration by vegetation or soil, or 3, storing stormwater runoff for reuse. So the fact sheet was created to help the public better understand that GI is very important for managing stormwater and that these BMPs more effectively maintain or mimic natural hydrology and provide environmental benefits by infiltrating precipitation to replenish groundwater and stream base flow, evapotranspiring and evaporating precipitation to reduce stormwater discharge volumes, and intercepting precipitation to reduce runoff and erosion. Now, there are also co-benefits to using GI, and they include a reduction in the urban heat island effect, decreased energy use, removal of pollutants from the air through greater utilization of vegetation, beautification of public spaces, and increased property values. So where do we find the GI fact sheet? Well, last year we updated njstormwater.org, which is our stormwater homepage, and it's now in the new format that you see. The B&P manual is found by clicking on the image of the lighthouse. It should be in the upper right-hand corner of the stack of images, or even the linked text that appears below it. So once you're on the page for the B&P manual, the fact sheet about meeting the green infrastructure requirements is now found on the lower right corner, down here in the red, where the red oval is. It's a PDF file. Now, one thing I want you to note is that I've updated the slide here to show that the web page was updated on October 9th. This was the most recent update since the slides were made for the class. So you will see the pages regularly updated. Just always refresh your browser and make sure you are working with the latest information. All right, or you can use the link that's in the green at the top of this page in your full page slides. So the fact sheet is an 8-page document that presents the information in NJAC 7:8, which we know as the Stormwater Management Rules, or more simply referred to as the rules. So this is just a screen snip of a portion of the cover page. All right, but next we're going to look at what's in the fact sheet. But you know what, before we do that, let's see what the rules say about GI. All right, so in the rules, we can find the requirement where underlined in red on this screen, taken from the rules. All right, the yellow highlighted area right above the red underline. Where is that? Okay, there we go. Says the design and performance standards for groundwater recharge, water quality, and quantity control must be met using GI. So under item F in this subchapter is where you will find the tables 1, 2, and 3, and it is these tables which list BMPs and identify them as either 1 as GI, or 2 as GI requiring a waiver or variance if used for other than quantity control, or 3 as non-GI BMPs. This was covered in Module 1 in our overview presentation. Now, Anthony also touched on this in How to Review a Project Part 1 from Tuesday. The tables have important notes and footnotes that should not be overlooked. And if you need help understanding them, please contact us. So the takeaway from this is that, first of all, the rules require a project meet the design and performance standards using GI. So that means usually Table 1 BMPs will be used as they satisfy all of the requirements. So Table 2 BMPs, as we covered earlier, can be used to address stormwater runoff quantity control. When used for the other design and performance standards, Table 2 BMPs require a waiver or variance, and we'll see a refresher on those presented by Manesh in the next presentation. Now, remember, Table 3 BMPs are not GI and therefore will also require a waiver or variance to meet any of the design and performance standards. So that brings us to the end of item 2 on the slide, which says that GI is to be used in accordance with subchapter 5.3, which I'll discover next. And it's this section where the rules identify which of the GI BMPs have fixed contributory drainage area limits. Now remember, a contributory drainage area is defined in the rules as the area that drains to a stormwater management measure, excluding the area of the measure itself. On the fact sheet, below the first paragraph on page 1, these limits are restated. So take note that the GI BMPs found in Chapter 9 of the BMP manual that are not listed here have one or more design components that limit the size of the contributory drainage area. So for example, Grass swales have geometric constraints and a maximum depth of flow limitation that is 2 inches. And this design criteria will impact how much of an area can drain to a given grass swale. All right, next is how to implement GI into a project or make sure it has been properly implemented. So the fact sheet even includes a rubric to help anyone evaluate if GI has been properly implemented. So with any design, the 3 questions shown here must all be answered with a yes for the project to meet the GI rule requirement. So the reviewer is to confirm that the answers are correct. So let's go through these questions individually. So GI manages stormwater close to its source. Well, what do we mean by that? Well, green infrastructure mimics the natural hydrologic cycle. So although stormwater traveling from this point over on the right has a lot farther to go than a drop falling over here on the left side of the site, remember that clearing, grading, and paving results in much shorter values that are calculated for runoff travel times because pavement is much smoother than the natural terrain. Plus, we typically use uniform and flatter slopes for our parking lots. So we can no longer direct a runoff to a solitary basin. There should be more opportunities to treat runoff over the right side of the site that you see here. The basin is not close enough to the runoff generated by the far right of this site. Okay, so there's also little opportunity for the stormwater to interact with vegetation or soil in this particular layout. So in conclusion, this layout is not GI. So imagine an old factory on a fully paved site in an urban area. Runoff from the roof drained to the parking lot and then went to the street. So we're going to redesign the site using green infrastructure. So a fully impervious 3-acre site in an urban redevelopment area is proposed for redevelopment. And that will consist of a 1-acre building plus 40,000 square feet or 0.918 acres of parking areas and internal driveways, and also a 1-acre overflow parking area. A green roof and an underground cistern are proposed to manage the rooftop runoff from the 1-acre building. Stormwater islands designed to infiltrate into the subsoil are proposed to manage runoff from some of the parking areas and the internal driveways. Also, a permeable asphalt system designed to infiltrate into the subsoil is proposed to manage runoff from the overflow parking area. So here's what that would look like. The proposed redevelopment is a major development since it disturbs 1 or more acres and therefore is subject to the design and performance standard in the rules. However, because it is an urban redevelopment area and it was previously completely disturbed and was fully impervious, groundwater recharge is not needed. Also, the proposed condition reduces the impervious surface present on the site in the proposed condition. All right, but this profile view illustrates what is meant by placing BMPs close to the source of runoff. And this is the plan view of the site we just saw in profile. All right, so since the existing site is so highly impervious, many of the non-structural stormwater management strategies that were required by the local MSWMP could not easily be implemented on site. However, due to the proposed GI practices, the project itself breaks up or disconnects the flow of runoff over impervious surfaces and provides low maintenance landscaping that encourages retention and planting of native vegetation and minimizes the use of lawns, fertilizers, and pesticides. So in this example, all stormwater runoff generated by the redevelopment is managed close to its source. So we can answer unequivocally with a yes to the first question on the GI fact sheet. The next question to be asked is if the GI BMPs are dispersed throughout the site. So the previous site was certainly a good example of spreading BMPs throughout the site, and here's another. The parking stalls themselves are pervious pavement, and they're separated by impervious pavement aisles graded to direct runoff to the pervious areas. Roof runoff also drains to the subsurface storage beds below the pervious pavement parking stalls at either end without exceeding the drainage area limits. So yes, we can answer yes for this site as well. All right, so let's look at a third site. The requirement to distribute GI throughout the site doesn't mean that multiple GI BMPs cannot be near each other. It's important that they be close to the source of runoff, like these dry wells are to the building for which they manage runoff. They are distributed because they're on 3 sides of the building. Now, if this is part of a larger site where there are additional GI BMPs, then this layout is fine and a separate discharge for each of the 7 dry wells is not necessary. So as long as no more than 1 acre of runoff is directed to any individual dry well, the drainage area limitations are met. And furthermore, to be GI, each of these dry wells must each function individually for the water quality and recharge storms. All right, now let's look at another example. The small-scale GI BMPs here are separated by berms and have contributory drainage areas below the maximum. However, all of the BMPs are concentrated in one area of the site. So look how far the building is from this cluster. There's also no stormwater BMPs over on the right side of the parking area. So therefore, the BMPs are not all near the sources of the runoff. So in conclusion, the BMP does not meet the definition of GI and it doesn't meet the rules. The last question to be asked is whether the contributory drainage area of the proposed GI BMP is less than or equal to the limitation found on the cover page of the fact sheet and in the rules at 7:8-5.3. Small-scale bioretention basins are ideal for use in parking lot islands and where one is typically used, albeit in the past, a grass strip at the edge of a parking lot or along a roadway. The drainage area limit for this BMP is 2.5 acres, and that's generally more than enough. Next, we're going to review an example with a drainage area map that clearly shows the limits draining to each of the proposed GI BMPs. So the goals of this part of the presentation are listed here, but we're just going to focus on the GI part. All right, we're going to look at what was proposed and then identify if and where the design falls short. All right, I will not have time today to discuss any potential solutions, okay? All right, so all reviews are going to require figuring out which standards apply and then checking them for compliance. So questions we must ask and answer are, what is the disturbance on site? Does it trigger major development? Will the project be required to do water quantity, groundwater recharge, water quality, and groundwater mounding? We will need to figure out all of that to see if they will apply in this review and how they'll be addressed using green infrastructure as required by the rules. So it's important to know what the site looks like and what the pre-construction conditions are and what is the existing land cover. So we also need the soil testing information. So first, let's look and see what's going on in our example. All right, the property in question is a farm that's been in existence for many decades. It comprises over 18 acres. The frontage road running east to west is a county route with sizable traffic volumes. That is up here. Okay. All right. The property is adjacent to some forested properties along the rear lot line, which is also a stream corridor for a freshwater non-trout tributary. The property drains towards the stream, which then flows to the south before crossing under the roadway east of the property via a culvert. Here's the topographic view with the stream, the wetlands delineation, and the various 100-foot wetlands and riparian buffers shown as some various dashed lines. The green arrows denote the general direction in which the runoff flows across the existing land surface. The proposed development includes the clearing and grading of the property, construction of 25 single-family homes, widening of the existing road found on the right side of the plan, okay, and another internal roadway. Both roadways will be constructed with 6-inch curbs and will each terminate in a cul-de-sac having a 50-foot radius. The stormwater management report indicated 4.7 acres of impervious cover is proposed, but it didn't have a breakdown dividing it into motor vehicle surface versus rooftop. So that breakdown is important with the rule amendments. I started checking the coverages, and the homes are about 0.35 acres each on average, so that totals up to 8.75 acres. The proposed roadways are 28 feet in width, and by my estimate, that's 70,000 square feet or so, or 1.6 acres of new motor vehicle surface that is proposed. Additionally, the existing portion of the roadway along the east side of the property will be newly collected where no collection system existed before. So it also counts towards the net increase in motor vehicle surface. So clearly these totals exceed the thresholds for major development. So for this project, compliance must be demonstrated with the GI requirement. We have water quality, stormwater runoff quantity control, groundwater recharge, and if infiltration is proposed, groundwater mounding, plus the safety requirements and of course maintenance. So to address water quality and the GI requirement, 4 small-scale bioretention basins with underdrains are proposed, and here's where they will be located. So first, let's look at the soil exploration map, which indicates quite a number of test pits were completed, although at the time that this plan was prepared, only one central stormwater management basin was anticipated, and that's that sort of light blue area in the center of the site. So perhaps the preliminary concept predated the amendments to the stormwater management rules. But as you know, major development projects are required to use GI best management practices. They are smaller in scale and they treat stormwater runoff close to its source. So it's good that the designers realized the single basin approach would not be compliant, and then they went with multiple BMPs. So the reviewer, of course, would also want to check that for the revised design, the proper number of test pits and soil borings were performed. In this case, the soil testing report was not revised to meet the testing location requirements for the updated multi-basin layout. So anyway, from the test pit findings, the seasonal high water table was determined to be at depths between 3 and 6 feet, mainly because modeling was observed, and the teal color boxes that you see show the depths below existing grade. So where the depth is preceded on this screen by an asterisk, cemented soils were observed. Additionally, from test pits 10, 11, and 12, the tested permeability rates were far below the minimum field rate of 1 inch per hour, meaning GI BMPs designed to infiltrate could not be used. So lastly, there we go. All right, here's the approximate locations of the 4 proposed BMPs, so you can see which test pit most closely corresponds to which proposed basin. So let's look at the drainage area map for the proposed conditions next. All right, so here it is, and you can see that the contributory drainage area to each under-drained small-scale bioretention basin is less than the allowed maximum of 2.5 acres as specified in NJAC 7:8-5.3b. So that seems to meet one of the requirements for green infrastructure. However, the placement of the basins is too far from the source of runoff. Plus, the GI BMPs should be distributed throughout the site and not grouped close together as they are here. Why? Well, the motor vehicle surfaces are generating runoff requiring treatment, and the GI BMPs need to be near them. If rooftop runoff or runoff from other impervious cover that is not motor vehicle surface is commingling with runoff from the motor vehicle surfaces, then the commingled runoff volume must be treated. But no information was provided showing where the roof runoff was going. So next, what we're going to do is we're going to look at each individual basin. All right. So Basin 1 is at the left side of the image, shaded in pink, next to the cul-de-sac to the west on the property. Runoff is collected in lawn area inlets and piped to the basin. Plus, the cul-de-sac is graded so that runoff flows to the east more than 50 feet along the curb to the inlet on the piping run, even though the basin is so close to the huge area of the pavement. All right, basin 2, shown here in blue, is not close enough to the source of the runoff, all right, which, as previously stated, is a GI requirement. Its contributory drainage area is also shaded in blue, and it's far away from the center of the property where the basin is found. Now, basin 3, it's the area towards the right that's also shaded in pink. The basin is too far from the motor vehicle surfaces like the entrance roadway and the internal roadway. The yellow area is for basin number 4, and look how far runoff has to travel down the side road before collecting in inlets and being piped to the basin. So even though the drainage areas are below the contributory limit, none of the BMPs reported as being GI BMPs are close to the source of runoff, nor are they distributed throughout the site. So this layout alone does not meet the GI requirements. Lastly, there's a lighter green area in the center that has roof area generated runoff. It's not detained, so that will be an issue when we address how the site complies with the quantity control design and performance standards. All right, so we know that the design does not meet the requirement to use GI, so we're going to call that strike 1. All right. Let's take a look at other instances in which the project does not comply with the rules. So here's a basin section detail. All right, the details for each of the BMPs otherwise show that most of the requirements for online bioretention systems with underdrains with weirs and orifices to attenuate discharge from the larger design storm. Well, so far, so good. However, I didn't see the bioretention media specification, so that would definitely be something to add in my review letter. I also didn't see a maintenance plan, so without these 2 items, the BMPs don't merit their TSS removal rating. So that means they don't meet the water quality standard. And this would also go into the review letter, and we'll call that strike 2. All right. So interestingly, the stormwater calculations that were prepared earlier in 2022, they used the Type 3 storm distribution for the 2, 10, and 100-year design storms. But as per the 2021 publication of Chapter 5, NOAA C and NOAA D distributions are now used. So that would also go in the review letter and new calculations would be required. So far, it's not looking so good for meeting the runoff quantity control standard. So for now, I'm going to mark that also as non-compliant. For groundwater recharge, the project states that the project demonstrates compliance with subsection 5.4 of the rules because all of the runoff is infiltrated. No, that's another error. They are only proposing under-drained BMPs. So maybe the designer thought that the movement of water through the planting media was good enough to meet the requirement, but under-drained systems are not infiltration BMPs and cannot be used to meet the groundwater recharge requirement. So furthermore, the narrative in the Stormwater report even stated that these under-drained basins were sufficient to address groundwater recharge, claiming the proposed 2-year hydrograph volume is less than the existing 2-year volume that's shown here in the excerpt in the red box. However, the narrative is incorrect. The report calculations themselves show an increase in the volume of runoff generated by the proposed design. So once more, they don't demonstrate quantity control compliance, and we'll let them know that the project will have to be revised along with the narrative. Now, one other thing that I would probably add to the review letter is that if the design were actually infiltrating runoff into the underlying soils, then a groundwater mounding analysis would have to be included. So that means if pervious pavement, rain gardens, small planting areas, or dry wells are incorporated into the design, then their impacts on the nearby structures would be required in addition to the assessment of the impacts of infiltrating stormwater into the BMP itself. All right, so that is everything I have for this. So let's see, what did we cover today? All right, we covered what we mean by green infrastructure, which we abbreviate as GI, and that is a stormwater management measure that manages stormwater runoff close to its source by treating stormwater runoff through infiltration into the subsoil or treating stormwater runoff through filtration by vegetation or soil, or storing stormwater runoff for reuse. The fact sheet was created to help the public better understand GI and how to implement it, along with examples of clustering BMPs that are not considered green infrastructure. Now, to address water quality, groundwater recharge, and runoff quantity control, the rules require green infrastructure be used, and by that I mean used correctly. So answering 3 questions when you review a design will check if the GI is properly implemented on a site, meaning the GI BMPs are located close to the source of runoff, they are dispersed throughout the site, and the drainage area limitations are met. So I hope that you found the example enlightening, and I hope that you will think about how GI can fit into your particular location. So that about does it for me, and thank you very much for your attention. I will ask the moderator if there are any questions at this time.
I will answer the question in chat. Please continue the presentation. Next one by Minesh. Thank you.
All right, so as Changi said, up next is Manesh with example 2. Thanks, everyone.
All right, thanks, Lisa. So hello again. We're just going to get right into plan review example number 2. So the goals of this presentation are the same as those for the prior example. We will focus on whether the project meets the requirements for green infrastructure, and we'll look at what was proposed and identify where the design falls short. So let's take a look at what's going on in our example. We'll start with what the site looks like, what the pre-construction conditions are, and what the existing land cover is. So the property in question is a site covering roughly 11.7 acres that is primarily undeveloped and wooded, containing the abandoned ruins of a single-family residence and related outbuildings on the northwest portion of the site. The site does run alongside a state highway, as you can see in the image. To the west of the property is a conservation easement containing a ponded area that's draining to a tributary of a local river. The site itself receives stormwater runoff draining from the east side of the divided highway, and there are some mapped wetlands areas on the site as well. So now let's take a look at the drainage area map for the existing conditions. So here's a topographic view. As you can see, the arrows here depict how the site would flow. Some flow from the road to the northwest and some flow from the highway to the east. Everything ultimately is going to be flowing towards the southwest portion of the site, with the high point of the site being in the northern area. The proposed development includes the clearing and grading of the property. There will be a construction of 152 age-restricted affordable housing units in a single multi-story building, a single access driveway, a surface level parking, and multiple stormwater basins that will discharge to the southwest corner of the property to support the existing drainage patterns. The project will be constructed in 2 phases. The first will include 84 units, and the second will be 68 units, which are located on the left side of the building as shown. From the stormwater management report, the narrative states there are 3 small-scale infiltration basins along the southern border that are designed to provide extended detention of the larger storm designs, plus a northeast detention basin for the off-site runoff entering the site to the north and east. So immediately there's a big issue with this design. All 3 of the basins that are proposed to meet the green infrastructure requirement, they're all grouped at the southern side of the project. So clustering these BMPs together is not compliant with the green infrastructure requirement. Remember, the BMPs have to be distributed throughout the site and manage stormwater close to its source. The proposed design is going to rely upon infiltration of runoff to meet the groundwater recharge requirement and water quality. Let's look at the web soil survey next, and followed by the soil testing data before we evaluate the overall design a little further. So as you see here from the soil survey, the site is mapped as HSGA, which is promising for infiltration. So let's look at the soil testing findings next. 2 sets of soil investigations were conducted. A total of 20 test pits were performed. The first group, shown in green, are from April 2021, and the second group, shown in blue, are from January 2022. So I've superimposed the 3 proposed small-scale infiltration basins onto the soil testing map just to show which test pits correspond to the respective basins. Your review would also include a check of whether a sufficient number of test pits and soil borings were performed, along with the depth of the investigation, which I'm not going to be covering here because we're really going to be focusing on the green infrastructure aspect. I've also added the depth at which the logs show the soil permeability was determined, taking note that groundwater was not encountered at any of these locations. The brown shaded rectangles denote results for other test pits, and for test pit number 3 and 5, groundwater was encountered at 5.5 feet below existing grade. For test pit 6, groundwater was encountered at 6 feet below grade. And lastly, a perched water table was found for test pit 8 at 10 feet below grade. As with the blue shaded test pits, groundwater was not encountered at the ones that I did not call out. So the report shows quite a variation in the test results for permeability. So let's look at the table of the testing results. So here's that table, and I've circled the locations where the field tested permeabilities were less than 1 inch per hour. Unless soil replacement is proposed, these locations are not really suitable for infiltration types of BMPs. So given the low permeabilities at the encircled test pits, we will have a problem with the ability of the orange and yellow shaded basins to drain properly, and we'll add this to the review letter. So next, let's look at information found in the stormwater report, which states the 3 basins are designed as small-scale infiltration basins, but we really have to check if they are. So this is the node diagram from the stormwater management report. These are usually up front in the materials that are submitted, and I use them to look at how the site is modeled and make notations as I start my review. Basins 27P, 24P, and 38P are the basins numbered 1 through 3 respectively. They have superimposed the inflow areas taken from the basin summary reports, with the totals appearing in the brown shaded boxes. The node report shows basin 1 draining to basin 2, and that will then drain to basin 3, such that the contributory drainage areas appear to exceed the 2.5 acre limitation that's established in the rules and in the GI fact sheet. The connections between BMPs is something that has to be checked to determine if this is true. Remember from the fact sheet presentation that the GI BMPs have to function individually for the water quality and groundwater recharge design storms, and each has to meet the contributory drainage area limitation. So perhaps the drainage area map can provide clarification, and after that, we'll look at the construction details to see how this design will function. Here's the drainage area map for the post-construction condition. This shows the contributory drainage to each small-scale bioretention basin is less than the allowed maximum of 2.5 acres, which appears to demonstrate compliance with NJDC 7:8-5.3b. But we have to dig further to evaluate how individually versus connected the basins perform when it comes to the water quality, the 2, the 10, and the 100-year design storms. So before we dive into the construction details, I just want to say that I'm not including further review information for quantity control and groundwater recharge. For the required groundwater mounting analysis for infiltration BMPs, the only analysis was for basin 1, and the most restrictive hydraulic conductivity with the factor of safety was not used in the calculations. So this could also be in the review letter. All right, so here's a close-up image taken from the plans, and I've added construction details that shed light on how these basins function. Basin 1 is on the right, and A-9 is the outlet control structure for it. As you see, the top grate is the sole means by which runoff discharges from the basin. Since the grate is at elevation 63, the water quality design storm infiltrates, and the 2, 10, and 100-year storms overtop the grate and flow to basin 2, which has outlet structure B11. And if you look at the detail, the lowest orifice has an invert of 50, which is below the water surface elevation of the water quality design storm that's contributory to basin 2. So basin 2 wouldn't meet the design criteria for infiltration basins according to our BMP manual. And then similarly, the lowest orifice at OSC-10 is below the water surface elevation of the water quality design storm. So in conclusion, basins 2 and 3 do not meet the design criteria for infiltration basins according to the BMP manual and will not merit the 80% TSS removal rating. These contributory drainage areas would most likely be larger than the ones that you would find in Table 5.1. They would then be more suited for those in Table 5.2, which would require a variance before they can be used for quality and recharge. Waivers are for the enlargement of an existing public roadway or railroad or the construction or expansion of a public pedestrian access, which this project is not. So the next slide will revisit the subject of variances. There are strict standards to be met in order to grant a variance, as we've discussed. More specifically, the municipality has to have a mitigation plan in place that identifies what measures are necessary, potential mitigation projects, and/or criteria to evaluate mitigation projects that can be used to offset the deficit created by granting a variance. Additionally, the conditions that are shown here, in part from the rules, must be met. the applicant has to demonstrate it is technically impracticable to meet one or more design and performance standards on site. And those reasons can only be for engineering, environmental, or safety-based. Furthermore, the variance cannot be for the entire site unless an analysis is provided for each drainage area within the site. The applicant also has to demonstrate maximum possible compliance is provided by the design. Don't forget, there's also a reporting requirement for variances. What's not shown in this excerpt is item 3, which is about the mitigation plan, which has to be within the same HUC 14 and approved no later than the preliminary or final site plan of the project. Moreover, if the variance is for green infrastructure, then the mitigation plan must use green infrastructure BMPs to manage an equivalent or greater area of motor vehicle surface. There are 7 other parts to the mitigation plan from this section of the rules that I've not covered here. But in short, a municipality cannot grant a variance now like it may have done in the past. Since information was also not provided on mitigation projects, this project is not compliant with the rules. So let's conclude the review of this example by answering the 3 green infrastructure questions for the proposed design, even though only one small-scale infiltration basin was actually proposed. So they must all be answered with a yes for the project to meet the green infrastructure rule requirement. So number 1, the BMPs were not located next to the parking areas, so the first answer is no. Number 2, are the BMPs distributed throughout the site? Well, the BMPs were all located near each other along the southern property line, so the answer here is also going to be no. And number 3, are the drainage area limitations met? It didn't look like basins 2 and 3 infiltrated the water quality design storm and were instead discharging downstream during the water quality design storm. So the answer here again is likely no. So to wrap things up, this project does not comply with the requirements to use green infrastructure to meet the design and performance standards for water quality, groundwater recharge, and stormwater runoff quantity control. So that about does it for me. Thank you for your attention. Before we move on to the next presentation, Changyi, are there any questions that need to be addressed?
I think I addressed all the questions posted in the chat. So I will continue next presentation. Please hold down for a moment. Let me when I switch the sharing. Good afternoon, everyone. This is Chen Yu. I'm going to present the third example from the project that we saw in our MS4 audit program. So the goal of the review for stormwater management project is to review the site plan and the stormwater management report, and also identify any errors with the design. So first thing to ask is, this project is a major development or not a major development. So you have to look into the municipality's stormwater control ordinance. And for this project, the municipality adopted SCO pursuant to the stormwater management rule adopted on March 2nd, 2020. So which is what we call the GI rules. And under the GI rules, the definition of major development as a disturbance of 1 acre, 1 or more acres of land, or increase of a quarter acres of regulated impervious surface, and all regulated motor vehicle service. So in order to check the disturbance and the increased regulated motor vehicle service and also the regulated impervious service, we need to check the land covers of the pre-construction condition and the proposed conditions and the scope of disturbance. So let's take a look of the site plan. So the site plan, you can see that it's a development that has a lot of disturbance and also impervious and motor vehicle service. So let's take a look of the existing conditions. And for the existing conditions, we have to check the 5 years from the day they submit application and see whether within the 5 years, whether there's a land cover change, whether there's a land cover that would have the least potential to generate runoff. So from this project was submitted in 2021. So we look back, there's an aerial photo available in 2015, and from the aerial photos, we can see that the project there's not land cover changes during the past 5 years. So we can assume that the land cover right now shown on the site plan survey and also on the aerial photos shows the project site. The major land cover is wooded area and has some impervious surface. So compare the pre and the post construction condition. We definitely know that this project would disturb more than 1 acre, and also would have more than a quarter acres of regulated motor vehicle service and regulated impervious service. So this project is definition of major development. So when a project is a major development, we have to look into 4 standards. The first one is water quantity. So definitely this project needs to meet the water quantity standards. The second one is water quality. And you can see that the project has increased in regulated motor vehicle service greater than a quarter acres. So it is required. And then since the project has a huge coverage of impervious service, definitely the groundwater recharge is required. So let's look into the GI infrastructure requirement. As we said, this project was submitted after the township adopt the SCO pursuant to the GI rules. So let's take of so this project need to meet the GI rules. Here's a table of the GI BMP, the stormwater management BMP they proposed. So including 6 small-scale bioretention gardens, 2 small-scale infiltration basins, and 1 non-small-scale infiltration basin. In accordance to the rules, our SCO, GI BMPs are required unless a variance from the strict compliance with the SCO is granted. Especially small-scale GI BMP has to be incorporated to comply with the stormwater runoff quality and groundwater recharge design. So we can see that one of the infiltration 4 has a contributory drainage area greater than 2.5 acres. So infiltration 4 is not a small scale GI BMPs. So this project does not meet the small scale GI, does not meet the GI rules. And next one, we want to look at whether the proposed GIBMP is close to its source. You can see that from the site plan, the blue highlighted area is the proposed GIBMPs. But you can see that on the upper left corner, the area has substantial impervious service and motor vehicle service, but there's no proposed small-scale GIBMP allocated on the area. So this project can be improved. Although this project, since it's already tried to distribute the basins, the BMPs over the site to treat the runoff from the close to its source, but it can be improved if they can move some BMPs to the upper left-hand corner. So after review the site and the proposed BMP, the next topic is to review the soil information. The first item of the soil information is the hydrological soil group of the site. HHG designation is the basis for estimating the runoff from the pre and post construction conditions. This site is approximately 7.5 acres that is classified as urban land sandy soil that doesn't have any HHG designation from the Web Soil Survey. Because the project did not perform soil testing to identify the HHG of the urban land sandy soil, the default HHG method should be used. This project is located in Coastal Plain. This one is in the Burlington County. For pre-construction condition, the soils on site should be assumed to be HSG-A soil. For the post-construction condition, HHD soil should be used. However, this project assumes HHGB for the 7.1 acres of unidentified HSG soil. So there's a mistake in the design. Around HSG designation of the on-site soil, we have a significant impact on the accuracy of the routing calculations of the stormwater runoff and the configuration and the sizing of BMP. We'll discuss this issue further in the water quantity standard section. And next one for the soil testing is to examine whether the soil exploration meets the requirement from Chapter 12. So here is some expert from the soil exploration requirements from Chapter 12. And for the number of the soil exploration, there are 3 requirements, 1 and 2, 3, 4. For requirement number 1 is for any non-small scale GI BMPs or non-GI BMPs. Requirement number 2 is for 1 or multiple infiltration BMPs, including small scale green infrastructure BMPs, each equal or less than 500 square feet in area. Requirement 3 is for 1 or more small scale green infrastructure BMPs that infiltrate runoff into subsoil where each GI BMP is greater than 500 square feet in area, excluding porous paving system. And also there are 2 requirements to give some flexibility of the soil exploration locations. Since in many cases, soil explorations are conducted prior to the detailed design of the stormwater BMPs and and also sometimes for other purpose, for example, geotechnical engineering. So the soil exploration may not exactly lie within the infiltration area of the proposed BMP. So some flexibility in the location of soil exploration is that if the new location of BMP is within 25 feet in any direction of all the original soil exploration locations, the soil exploration that is now within the infiltration area of a BMP can be still recognized as a valid location. Another additional flexibility in a soil profile is that the soil profile pit can substitute for a soil boring, but the soil boring cannot substitute for a soil profile pit. So under this requirement in Chapter 12, let's take a look of the soil exploration on the site. This is the soil testing map. The red dots are those soil test exploration being performed on the site, and the yellow highlighted area are those proposed BMPs infiltration area. So you can see some of the soil exploration fall within the infiltration area of the proposed BMP, but some of not. So we did a review and then have the summary in this table, and we identified that there are two proposed BMP that doesn't have valid soil exploration. After we review the soil number of soil explorations and also the locations of the soil testing, the next topic to discuss in the soil testing is the depth of the soil exploration, whether it meets the depth requirements. So I think you are already learned about the depth, so I'm not going to repeat it. And so from our review, there are a couple of the soil exploration that doesn't meet the depth requirements. Then next topic to review is the saturated soil hydraulic conductivity rates testing and also the season water table. So here's one example. We do see a lot of they have the soil profile pit, the soil profile log, and also have the description of the soil morphology in the submitted soil report. So here are two examples. One example is the infiltration 4 that they identify the redux morphic features at the 32 inches below the ground level, and also a water table was encountered at the 50 inches below the ground level. Since the season water table is higher than the observed water table, 32 inches, so the 32 inches is below the ground is recognized the depth of season water table. So this seawater table will be used to check whether there is a sufficient separation of seawater table from the lowest point of the BMP. So as shown in the detailed site plan, the profile of the BMP, you can see that it has the sufficient seawater table separation. And the another example of this project is that the encounter of the water table and the morphology observation at the same level. So it's all determined as 70 inches from the ground. So that we would use that to check the season water table separation. And for the saturated soil hydraulic conductivity rate, that the test must be conducted on the most hydraulically restrictive soil layers above the seawater table, but below the lowest point of the BMP. And here a summary of the findings. We can see that some of the BMP are not tested below the lowest point of BMP. They even tested at the depth that's to be excavated out. So it's not valid. And in this project, cubic per millimeter test was conducted. However, some of the tests was not valid. They are not tested at the hydraulically most restricted soil layer. So the test report for the hydraulic conductivity should be compared with the seawater table and all the soil log to see whether the test was performed at the hydraulically most restricted layer. So for those tests doesn't meet the requirement, cannot be recognized. And another point to mention is that if valid multiple saturated soil hydraulic conductivity rates in a BMP was obtained, the lowest value should be used to represent the tested saturated soil hydraulic conductivity rate, not the average. So for example, infiltration 4 has 4 tested results. The lowest value is 14.89 inches. So this one should be used as the tested saturated soil hydraulic conductivity rate, but which means 7.45 inch per hour should be used as a design saturated soil hydraulic conductivity rate. So after we review the soil information, we have the understanding of how the site looks like. So next topic will move to whether the site meets the water quantity requirements. So the first thing to check is that whether the routing calculation use the correct rainfall distribution, rainfall depth, and dimension that's unit hydrograph. This site is located in coastal plain and in the area of region C of the NOAA rainfall distribution. So therefore, the rainfall distribution should use type C, and the DUS should use the Delmarva. So the rainfall depth in this project, they use the county average of 24-hour rainfall. That's acceptable. And since this project was submitted to the township, because the township adopt HCO is only up to the rule amendment up to March 3rd, 2020. So for this project, it doesn't have to use the projected of the future rainfall in the design, as the current rule required. So when in quantity standard review, we will check whether the CN number is correct. And in this case, the CN, the design report used the HHB in the GB in the routing calculation, which is wrong. So that will affect the selection of the CN number. So default HHGA soil should be used. So there will be the CN number should be chosen from A soil. And for the post-construction, it's the default soil should be D soil. So the CN number should be chosen from the D soil. So the consequence of that will be overestimate the pre-construction runoff volume, peak flow rates, and underestimate the post-construction runoff volume and peak flow rate. So when you review the peak flow rate reduction rate for 2 stone, we would have to carefully review and may have asked the design engineer to correct those errors before they can before we can have a valid review. So like here. So then next topic is the whether you will see the impervious and pervious was separately calculated. For this project, they have from the routing calculation, we can see that the impervious pervious was calculated separately, which is okay. And for quantity, the next thing we want to review is the time of concentration. Time of concentration is would have a significant effect on the peak flow rate. So for the screenshots of the routing calculation, you can see the Manning's equation for the pre-construction condition was correctly selected because the drainage is a wooded condition. And the street flow density 100 feet, which is acceptable for the pre-construction condition. And the shallow concentrated flow rate should be used the land cover in accordance with the NEH, which distinguish differently from the vegetated covers. And the post-construction condition on the right seems to suggest that the contributory drainage area to the bioretention one is not impervious surface. So we will double check whether that the T sub C is correctly calculated. So we take a look of the aerial photos and the proposed site plan. We can see that, yeah, the bioretention basin one that will take the runoff from previous land cover, so that the assumption of T sub C is correct. And another thing we want to check is the water quantity. For the exfiltration, if they use exfiltration in their routing calculation, use of the exfiltration in a small scale GIBMP is allowed, but subject to some conditions. So here is some brief of the conditions. Exfiltration can be used in small-scale GIBMPs only if the soil testing must fully comply with Chapter 12. The design of the BMP must comply with all the chapter criteria in Chapter 9. Pre-treatment required for contributory drainage area greater than 1 acre. Exfiltration cannot be used in any BMP design with the underdrain system. So let's take a look of the one example of this one. Sorry, there's a typo on the slide. If you have the handout, the drainage area in the handout is 2.71 acre. Actually, it should be 2.17. So let's take a look. Infiltration 1, the soil testing, as we saw from the soil report, are valid. And the drainage area is 2.17 acres. So pre-treatment is required. And we can see that they do have a pre-treatment. And this infiltration 1 infiltrate into subsoil. So exfiltration for this proposed infiltration 1 is can be used in the routing calculation. And also we review other all the proposed BMPs, and we found some issues. Here is a summary of those issues. Infiltration for is not a small scale GIBMPs because it exceeds the 2.5 acres of drainage area. So it cannot use exfiltration in the routing calculation. Biogarden 1367 do not have valid permeability test result, so they cannot use exfiltration in the routing. And because they cannot use the exfiltration, the volume and the water label would have to be revised. So the outlet, all of it, everything, it should be adjusted based on the routing calculation without exfiltration. Or they can alternatively, they can go back to do soil testing, get the valid soil results, and also modify the drainage area so they can continue to use exfiltration in the routing calculation. And the other issue is also associated with the soil, is that the routing calculation are based on HHG soil, where the soil is urban, then covered without any HHG designation. So the default HHG soil in the pre-construction and default D soil in the post-construction should be used. So if as we said in previous slide, that would have the overestimate pre-construction peak flow rate and underestimate post-construction peak flow rate. So the table we found in the report saying that they meet the reduction requirement would be questionable. So if you have the situation like this in your review, you should ask the design engineer to revise the report and then do the reduction rate calculation again. So after the water quantity, we would review the water quality standards. The first thing to check is whether the small-scale GIBMP are used for water quality. As we said that the infiltration 4 is not a small-scale GIBMP, so it cannot be used for meeting water quality. And second issue we want to address is that the proposed water quality BMP should treat the entire water quality design storm runoff in the BMP. That's in our rules and also in the township SCO. So let's take a look of their proposed BMP. Here, it may not be that obvious to you, but from our review, it shows that by gardens 6 and 7, they do not contain the water quality runoff volume. As shown in the profile of the BMP, the water quality level is at 20.21 feet, but the top of the spillway is at 20.220. So because the spillway elevation is lower than the water, the level of the water quality design stone, so the portion of the water quality design stone volume will be discharged through the spillway without treatment. So these two proposed BMP doesn't provide the sufficient water quality treatment. And also, we want to check the BMP design, whether the configuration of the proposed BMPs meet the design criteria that in our BMP Chapter 9. So as the previous slide shows, there are some BMP that do not have valid soil exploration to determine the stormwater table and all the saturated soil hydraulic conductivity rate. So the separation of the stormwater table and the drain time may not be verified. And also we, for the bioretention system, there are requirements for the soil bed, for the media, and also for the, here's a requirement from the BMP. So you will take a look of the profile view of the site plan and to see whether on the site plan, it does show those requirements for the planting bed. And for this project, it does shows that. Then for the infiltration BMP, for the soil layer, it has also have the requirements. So same thing, you have to check the detailed drawings of each soil the detailed drawing of the profile of each proposed infiltration BMP, and to check whether they have those notations in the notes in the site plan that meets the requirements. And also here are the screenshots from the site plan. They do mention about the construction and without compaction, and all those requirements that being required in the design criteria from Chapter 9. So so that is the details you want to review when you examine the site plan. After the quantity, the next topic to be reviewed is the groundwater recharge. For this project, it proposed to infiltrate the difference of the 2-year storm. Although it's simple, but this project, from the soil testing, we know that they did not use the correct hydraulic soil group in the design. So the volume it would not be correct. So they will have to correct the report to use the corrected HSG to calculate the volume and revise the report accordingly. And because those proposed BMP are to infiltrate runoff into subsoil, so groundwater mounting analysis is required. So here is the screenshots from their site plan, from their report, and have those numbers. And their estimate is the mounting height is 4.637 feet. And on the right-hand side are the highlights of their input. So we would like to also review whether those inputs are correct. So first of all, we review whether the recharge rate is correct. they use exfiltration rate 10 inch per hour in the grouting. So 10 inch per hour should be also be used as the infiltration rate in the mounting analysis. And for the horizontal infiltration rate is 5 times of the recharge rate in the coastal plain. So you should use 50 inch per hour. And the total volume infiltration during the 100-year storm is 0.155 acre feet. So from that, you can calculate the infiltration duration, and it should be 15.82 hours. So those numbers are not a state input. So we run the hand-touch spreadsheet and found that the correct mounting height should be 3.542 feet. So use that number, we go back to check the compare with the Stormwater table, and in the profile view of the proposed BMP, we found the mounting height is higher than the bottom, the basin bottom of the infiltration basin 2, for example. So they may adjust the recharge rate up to 0.5 inch per hour, then down to 0.5 inch per hour, and also within 72 hours, and to see whether the height will be lower. If that's lower than the basin bottom, that will be fine. But one issue, again, is that the soil, the hydraulic soil group is not correctly assigned in the calculation. So the runoff volume in the post-construction condition, they are underestimated. So in the routing, the volume to be infiltrated or exfiltrated are less than what it should be. So they may have to correct the errors and rerun the routing and do the groundwater mounting analysis again. After review those performance and design standard, we have to review the maintenance plan. And here are the screenshot of the maintenance plan. Since okay, they have the restriction, they have the responsible parties designation, have those log for the inspection and also maintenance work. But we found that their maintenance plan does not have the cost estimate, and which is required by the rules. And also that the maintenance plan has to be recorded on deed, but we did not see that record from the township. So a summary of this project after we review is that the soil, they did not use the correct default soil when there's urban land in the from the soil survey, and they don't have sufficient soil exploration and insufficient depth, and they did not have the sufficient saturated soil hydraulic conductivity rate. And for the water quality, some of the basins did not have the sufficient storage volume for the water quality design storm. And non-small scale BMP is used for water quality without getting variance from the SCO. And for water quantity, because the incorrect HSG designation will cause the wrong of volume and pico flow rate calculation, so that should be revised. And some of the BMPs that doesn't have meeting the condition to use exfiltration in the routing calculation, they should have revised their routing calculation. For groundwater recharge, again, is the incorrect HSG designation. They have to revise the report and to do the evaluation again. Mounting analysis, they have the wrong soil conductivity rates for the infiltration durations, and also, as I said, that their HHG, wrong HHG destination would cause the wrong of volume. So they may have to revise the plan and also the calculation. And for the management, there's no cost estimate. So here is the one quick review of the project we encountered during the audit program. If you have questions, please contact me. And I know it's been 1.5 hours, so we will take a 10 minutes break while I will answer a question that's been posted in the chat. So we will come back at 2:40. Thank you.
Hello, everyone. I saw a few questions in the chat about the quiz not being open, and we're just taking a quick break, and then we will be taking the quiz. So we're going to be coming back at 2:40, and that's when we're going to get into the quiz. So we'll see you all at that time to start the quiz. Thanks.
Hey, all right, sorry, Christina, this is me calling back. All right, so I have one quick question, right? So I'm looking at my pay stub, my most recent. Go on.
Yeah, sorry. It sounds like someone had a question, but then they cut out midway through the question. So you might have accidentally muted yourself. You can unmute if you wanted to ask a question.
For those of you who are asking about the quiz, it's not open yet. We will resume at 2:40 and get into the quiz at that time.
All right, welcome back, everyone. It's now 2:40, so I'm going to get right into quiz number 4. But before we start the quiz, we would like to remind you of a few important things. Upon conclusion of the course, we'll send out via email a course evaluation survey within the next couple weeks. The survey must be completed to receive either a certificate of course completion or a certificate issuing CPC credits. So if you review for an MS4 permittee, attended all 4 modules, complete all 4 quizzes, and are required by permit to complete this training every 5 years, you'll have to complete the survey before we send out the certificate of course completion. Likewise, if you are a professionally licensed engineer and you wish to receive a certificate issuing CPC credits, completion of the survey is prerequisite to us issuing any credits. Also, just to note that the slides and recordings for this training will be made available on the training webpage at the link here, and they'll be updated for future sessions of this course, which we typically try to host twice a year. As with the other quizzes, you may access the quiz in a few ways. The link at the top of the slide will take you to our training webpage, which has the link for quiz 4, along with the other quizzes and handouts. You may also use the direct SurveyMonkey link, which is shown here at the bottom of the slide and found in the chat. If you access the quiz on the same device that's being used for this meeting, make sure to use a separate tab so you are not removed from the meeting. Lastly, you may also use the QR code and take the quiz on your phone. Now, when you start the quiz, you'll notice some of the quiz questions will be new, and some will actually be repeats from previous quizzes. These are the questions that had the lowest correct answer percentage. So it's sort of a recap. As usual, we will review the quiz after everyone is finished. Please make sure to click Submit at the end of the quiz to get credit for completing it. So it's about 2:42 right now, and we're going to allot 20 minutes for the quiz. So let's meet back for review at 3:02 to do the review. So here's the link and the QR code again. You may begin the quiz, and we will meet back at 3:02 to conduct the review. Thank you.
Gotta figure out what the paycheck might be if they give it to us later.
All right, so it looks like almost everyone has completed the quiz. So we're going to get started with the quiz review now. Question 4. True or false? Green infrastructure, or GI, is defined in NJAC 7:8 as a stormwater management measure that manages stormwater close to its source by 1. Treating stormwater runoff through infiltration into subsoil, 2. Treating stormwater runoff through filtration by vegetation or soil, or 3. Storing stormwater runoff for reuse. And this statement is true. The definition shown in the question matches the language in the rules. Question 5. Which questions need to be answered yes when designing a major development to meet the GI requirements? Correct answer is all of the above. So, as found in the GI fact sheet, the stormwater must be managed close to its source, the BMPs must be distributed throughout the site, and the drainage area limitations, as applicable, must be met when designing a major development to meet the GI standards. Number 6. Which of the following GI BMPs has a contributory drainage area limit that is other than 2.5 acres? The correct answer is dry wells. Dry wells have a 1 acre contributory drainage area limit per NJAC 7:8 5.3b. This information was also in the slides from the GI fact sheet presentation. Number 7. Unless a variance is granted, which of the following BMPs cannot be used to meet the quantity control requirement? And the answer is extended detention basins from Chapter 11.2 of the BMP Manual. In accordance with NJAC 7:8 5.2, extended detention basins cannot be used unless a variance is granted. The presentation for example 2, specifically slide 12, included the information on what must be in place for a municipality to grant a variance from the GI requirements. Question 8, yes or no? Can GI BMPs be located near one another for the following scenario? There are 7 dry wells located adjacently on 3 sides of a large building. No more than 1 acre of roof runoff is directed to each individual dry well, and each dry well will function individually for the water quality and recharge storms. And the answer is yes. This material is covered on slide 13 of the GI fact sheet presentation from earlier today, and you can find more information about this setup on the GI fact sheet itself. The important factor here is making sure the answers to the 3 questions for GI are yes. Number 9. Which of the following is recognized as a co-benefit of using green infrastructure? And the answer is all of the above. As described on pages 1 and 2 of the green infrastructure fact sheet, all 3 of these are environmental, social, and economic co-benefits of using green infrastructure. Additional co-benefits include increased property values and the removal of pollutants from the air through greater utilization of vegetation. Question 10, yes or no? Is the interconnection between GI BMPs in the following scenario acceptable? A small-scale bioretention system infiltrates runoff for the water quality and groundwater recharge storm events, meeting the 2.5 acre contributory drainage area limitation. The 2, 10, and 100-year storm events are discharged from the small-scale bioretention system to a large-scale filtration basin, which is used only for water quantity. And the answer to this is yes. From NJAC 7:8 5.2, the downstream large-scale infiltration basin can only be used to meet the quantity control requirement and is not subject to the contributory drainage area limitations found in NJAC 7:8 5.3b. Additionally, the upstream small-scale bioretention system fully infiltrates the water quality design storm and the recharge storm. Number 11. Which of these can be used to demonstrate compliance with the water quantity design and performance standard? And the answer is B. Design stormwater management measures so that the post-construction peak runoff rates for the current and projected 2, 10, and 100-year storm events are 50, 75, and 80% respectively of the pre-construction peak runoff rates. Question 12, true or false? BMPs from Table 5-2 can be used to meet stormwater quality requirements without obtaining a waiver or variance from NJAC 7:8 5.3. This statement is false. BMPs from Table 5-2 can be used for stormwater runoff quantity only. For them to be used for stormwater runoff quality, a waiver or variance from 7:8 5.3 must be obtained. Number 13, yes or no? Can the Delmarva dimensionless unit hydrograph be used for the redevelopment of a 2-acre entirely impervious site located within the coastal plain? And the answer is no. The Delmarva dimensionless unit hydrograph must be used when modeling watersheds within the coastal plain region of New Jersey, with just a few exceptions. It cannot be used to size a manufactured treatment device, or MTD, as it may underestimate the peak flow rate entering the MTD. And for an entirely paved site, the significant surface storage associated with the coastal plain is no longer present, also resulting in underestimated peak flow rates if the Delmarva is used. Additionally, the Delmarva should only be used in areas that have an average watershed slope less than 5%. If any of these situations are proven to be present, the SCS standard dimensionless unit hydrograph must be used. Also, a side note on this subject, if the Delmarva is used in the pre-construction condition, it must also be used in the post-construction condition. Same idea goes for the SCS. Question 14. When determining the curve numbers for site design, the design engineer should assume that the condition of the existing cover is, correct answer is good condition. Pre-construction condition curve numbers should assume that vegetated areas are in good condition. Question 15. Soil testing logs prepared in accordance with Chapter 12 are required for which of the following BMPs? And the correct answer is E, all of the above. They all have a minimum separation from the seasonal high water table, which you can find in their respective BMP manual chapter. Soil testing would therefore be required for all of these to ensure that they meet the required separation. Question 16. What is required as part of the municipal stormwater management plan to grant variances or exemptions from the design and performance standards? And the right answer is C, mitigation plan. A municipality must have an approved mitigation plan as part of its municipal stormwater management plan to grant variances or exemptions from the design and performance standards. Question 17. Can an infiltration basin be designed with a perforated underdrain pipe as a means of discharging runoff from the basin? And the answer is no. An infiltration BMP cannot have an underdrain pipe if it wants to meet the criteria for an infiltration basin in the BMP manual. Question 18. Under the rules adopted on July 17, 2023, which of the following meets the groundwater recharge requirements? And the correct answer is D. The rules adopted on July 17, 2023 allow two options to meet this requirement. One is maintaining 100% of the average annual pre-construction groundwater recharge volume for the site. That option of meeting the requirement hasn't changed under the amended rules. The second option is to infiltrate the increase of stormwater runoff volume from pre-construction to post-construction for the projected 2-year storm. So the change under the newly adopted rules is that the storm event used under this option is the projected 2-year storm. Number 19, true or false? Under the rules adopted on July 17, 2023, the storm events used to meet the stormwater quantity standards shall consist of the current and projected 2, 10, and 100-year storm events as defined and determined pursuant to NJAC 7:8, 5.7, C, and D, respectively. And the answer is true. Under the rules adopted on July 17, 2023, both the current and projected design storm events are required to be used in the design of stormwater management BMPs to meet the stormwater runoff quantity control requirement. Number 20, true or false? Under the amended rules, a manufactured treatment device can be sized by using the rational method. And the answer is false. Under the amended rules, use of the NRCS methodology for stormwater runoff calculations is now required. All right, so that concludes the review for Quiz 4. Up next will be Lisa Haar with the MS4 program overview, followed by Lisa Schaefer with the updates to the BMP manual and other stormwater webpage items before we close out for the day with the training information. Please stand by while Lisa takes control.
Okay. Good afternoon, everyone. My name is Lisa Colleen Marie Haar, and I work as an environmental specialist in the Industrial Stormwater Permitting Unit in the Bureau of New Gypsy Stormwater Permitting and Water Quality Management. This presentation will kick off with a general overview of the Municipal Separate Storm Sewer System, also known as the MS4 Permitting Program. And there are 3 parts to this presentation. First, I provide the overview of MS4 program and address the updates that have been made to the most recent version of the permits. Then, Lisa Schaefer will take over to provide you with updates that have been made to the BMP manual and the webpage pursuant to adoption on July 17th of 2023 of the Stormwater Management Rule Amendments. After that, there will be some course-related information, including accreditation and evaluation. So please stick around until you're dismissed so you're marked complete for this module. Okay, let's get started. Department currently has permittees authorized under 3 types of MS4 permits: Tier A, Public Complex, and Highway Agency. There are currently 557 municipal permittees authorized under the Tier A permit. There are also a few municipalities that are not regulated under the Tier A permit because they do not have an MS4. These municipalities are not permitted under the Tier A because they are not entirely sewered by combined sewers and have a CSO permit, or because their storm sewer system is not publicly owned. The Tier A permit was last renewed in January of 2023. As part of the renewal process, the department addressed EPA's concern to reevaluate Tier A and Tier B designations to determine if any of the town's MS4 systems needed to be authorized under the Tier A permit. We found that all Tier B towns required reassignment due to population density increases in urban areas or due to discharges to impaired waters and/or waters with established TMDLs, which are total maximum daily load. The other MS4 permits are the Public Complex Permit and the Highway Agency Permit. We currently regulate 71 public complex facilities, which include public colleges, universities, hospitals, and our prisons. The public complex renewal was finalized in January 2024, and with that, 13 additional public complexes were authorized under the permit. There are 33 highway agencies regulated under the Highway Agency Permit, including state and county DOT roads. This includes agencies like the Turnpike Authority, Bridge Commissions, and the Parkway. The permit is currently due to expire at the end of this year, so it is currently in the renewal process and anticipated to be finalized by January 2025. MS4 permits include a wide range of requirements, including these key requirements noted here. We will be going into more detail regarding these requirements later in the presentation. In the meantime, take a look at this list. Just to note, we have only listed some of the requirements of all MS4 permits on this slide. Moving forward, I will be discussing the enhancements to the Tier A renewal that became effective January 1st, 2023. This is a list of notable changes in the Tier A permit renewal. I'll give you a moment to read the list, and then I'll go over some of the changes in more detail. Please note that the permit includes other changes. There are some new BMPs for maintenance yards. Excess salt and de-icing materials that have been deposited during spreading operations on all municipal roads and parking area must be removed within 72 hours after the end of storm events. We're asking for a dedicated stormwater page on each town's website. Employee training for municipal employees have been modified to once per year, and the street sweeping schedule has also changed. Many of these enhancements have been made to address water quality problems, such as impairments and TMDLs that affect waters throughout the state. There is no change to this permit condition. The 5G3 Master General Permit was recently renewed with a few changes and is available on our website. There are two minor changes to this condition. First, we clarified the permit language to say the design engineers cannot approve their own designs. Next, for any amendments to the Stormwater Management Rule, training sessions will be necessary for stormwater design reviewers. This is because attendance at this particular training, known as SWMDR, is only required once every 5 years, and we don't want to wait that long to train people on the amendments. Rule amendment training sessions pursuant to the rule adoption in July of last year were announced by the department on the website and via email to all stormwater program coordinators and people who have attended previous SWMDR courses. There is a completion list posted on the training webpage for all the reviewers who have completed the required rule amendment training. For any future rule amendments, this training requirement will also apply. Attendance is mandatory and must be completed within 1 year of adoption of the amendments to NJAC 7:8. We have added 2 new ordinances to the permit and have provided 2 new model ordinances to aid municipalities in the adoption process. The first new one is a privately owned salt storage ordinance requiring owners of private properties and businesses such as malls, shopping centers, etc., to properly store salt and other solid de-icing materials. The next one is a tree removal replacement ordinance to reduce runoff and to promote infiltration. Some towns may have already
may already have similar tree ordinances, and if their existing tree ordinances meets the minimum permit requirements, the town will not need to adopt our model. Note, we have completed evaluating the comments submitted on the 2 drafts and have finalized both model ordinances. Both are available on our website. There is no change related to labeling inlets. The change here is that all remaining storm inlets that have not yet been retrofitted due to utility work or paving projects must be retrofitted by December 1st, 2027. The entire structure can be replaced with an updated one, or you may attach a bolt-on plate to reduce the size of the vertical openings of the old inlet. In addition, all newly installed inlets must have a catch basin or other BMP to collect solids. We have also included an exemption for the catch basins on bridges. This is a condition that was in the 2004 Tier A permit that was removed in the 2009 permit renewal. The reason is that, at the time, it was viewed as a redundancy since municipalities are required to control erosion under the Standards for Soil Erosion and Sediment Control in New Jersey, NJAC 2:90-1. However, those standards only apply to construction sites, not necessarily to existing roadways, and we have received complaints about ongoing roadside erosions in various towns. The photo showed on this slide was taken by one of our enforcement officers who was investigating an erosion complaint. So, we have reintroduced this condition in the renewal. Erosion checks can be done while performing other stormwater inspections, so you don't need to schedule additional trips. If problems are identified, we allow 3 months to address it unless another time frame is authorized by the department. We want to clarify and point out that inlet inspections and catch basins inspections are different activities and have different schedules. The condition of storm drain inlets can be observed with a simple drive-by type of inspection and a quick sweep or shovel if the grade is clogged. For this reason, we require that all storm drain inlets are inspected every year. Catch basins, on the other hand, require additional work. The inspector must get out of the truck to inspect the inside of the catch basins to determine cleaning needs. For the Tier A permit, a minimum of 20% of the total must be addressed every year on a rotating basis so that all catch basins are inspected by the end of the permit cycle. This is a clarification to highlight that the permittee is required to properly inspect, clean, operate, and maintain all stormwater management measures. This is a catch-all condition since it refers to all remaining stormwater facilities not mentioned specifically in other permit conditions, such as stormwater management basins and manufactured treatment devices, known as MTDs. This program should define what conditions warrant cleaning, proper operation, and maintenance of any remaining stormwater infrastructure and establish an inspection schedule that is tailored to the permittee's characteristics and resources. If there is not an approved maintenance plan, the permittees can prepare a retroactive maintenance plan for certain infrastructure or inspect at least 4 times annually and after each rainfall of 1 inch or more. Keeping this in mind, that inspection logs must be maintained. This condition is for privately owned stormwater facilities. Permittees must have a program to ensure that cleaning and maintenance is performed as per approved maintenance plans. This was also required in previous Tier A and B permits. The private owner operator is responsible for providing documentation to the permittee that the stormwater facilities on their property are inspected annually and maintained according to approved maintenance plans. Operation and maintenance responsibilities may be assigned to commercial property owners, developers, and homeowners associations. However, individual homeowners cannot be assigned these responsibilities for stormwater facilities that were designed to manage stormwater for the surrounding areas. Permittees need to keep an inventory of the location and types of private stormwater facilities, as well as records of inspections, cleaning, maintenance, and repair work, and any problems and enforcement actions that were taken. The location and type of these private facilities will need to be included in the map created for Watershed Improvement Plan, which we'll cover a little later. Here you can see a list of the new or modified BMPs for maintenance yards and other ancillary operations. Note, the requirements that were previously included in Attachment E are now in the body of the permit, not in the attachment. All of the BMPs listed here have been modified from the 2018 permit, with the addition of a few new BMPs. For example, the Tier A permit will no longer authorize stormwater discharges from wood chipping or leaf composting activities, as these will be covered under the department's new wood waste recycling and leaf composting general permits. Some of the other changes include construction and demolition waste, wood waste, and yard trimmings may be stored on site for up to 6 months, but processing activities are not authorized. Scrap tires should be stored in a covered container or enclosure, but may be covered with a waterproof material on impervious surface. Inoperable vehicles or equipment may be stored on site, but must be inspected monthly to ensure that no fluids are leaking. All refuse containers and dumpsters that are stored outside must be covered at all times to prevent exposure to stormwater. If outside, bulk liquid materials must have secondary containment, such as spill containment dikes. Aggregate material, wood chips, and finished leaf compost and construction debris may be stored on site for up to 6 months, but processing activities are not authorized. Cold patch asphalt must be stored in a permanent structure or covered with a waterproof material on an impervious surface. These are the MS4 permit training requirements. The SPC training requirement is required for all stormwater program coordinators so that they know their responsibilities for implementing their stormwater program. This is required once per permit cycle. The link to the most recent certification list is shown on the slide. The employee training requirement includes implementing an employee training program to address permit components and stormwater pollution prevention plan, aka SP3 requirements. The swimmer training requirement is a stormwater management design review training, which you are doing now. The reviewer certification training list is updated regularly and posted on the training page, accessed to register for this course. The municipal board and governing body member training requirement is training for board and council members. This training is not intended to familiarize those members with the permit and permit requirement, which are generally not covered in other training requirement required of these individuals. This is required once per term. Original Tier A permittees should have already mapped their stormwater outfall pipes and will now need to add the rest of their infrastructure. Mapping is an entirely new condition for new Tier A permittees. This means mapping everything that collects or conveys stormwater, including outfalls, groundwater discharge point, interconnection, storm drain inlets, manholes, stormwater conveyance systems, pump stations, and any other stormwater facilities. Permittees are also required to map the property boundaries of maintenance yards and ancillary operations. Permittees must submit the MS4 infrastructure map electronically to the department by January 1st, 2026. Electronically does not mean a PDF sent via email. Rather, it means submitting georeferenced shapefiles, geodatabases, or AutoCAD files with all other non-applicability data stripped out. The department has developed a free mapping tool for permittees to use, and we can provide ArcGIS on licenses for free. Additionally, the tool has been updated to accommodate for any additional stormwater facilities and features that are required to be mapped. If the DEP mapping tool is used, data submitted is automatic. Otherwise, the files will need to be uploaded via the online stormwater document submittal service. The MS4 infrastructure map shall also be posted on the permittee's dedicated stormwater webpage when it is complete. Stream scouring inspection has been modified so all MS4 outfalls are to be inspected at least once every 5 years. Permittees must inspect 20% of the total annually on a rotation so that all outfalls have been inspected by the end of the 5-year permit cycle. Note that we broaden the scope of outfalls in the renewal to not just mean outfall pipes, so that will mean open conveyances as well. All new or newly identified outfalls, as well as complaints or reports of scouring, must be inspected within 30 days, and any reports of scouring needs to be remediated within 12 months of discovery. The requirement for illicit discharge detection and elimination inspections has been modified so all MS4 outfalls are inspected for illicit discharge at least once every 5 years. Permittees must inspect 20% of the total annually on a rotation so that all outfalls have been inspected by the end of the 5-year permit cycle. All new or newly identified outfall, as well as complaints or reports of illicit discharges, must be inspected within 30 days, and any reports of illicit discharges need to be remediated within 12 months of discovery. These inspections can be done in conjunction with the stream scouring inspections. There are many water quality impairments and resulting TMDLs that affect waters across the state. Some of these impairments affect fish and aquatic biota, drinking water intakes that supply the water we drink, and even in rivers and coastal waters where many of us swim every summer. Harmful algal blooms in many lakes due to water quality impairments are also occurring more frequently in the summer months. Some of these waters have no other discharges into them other than the local MS4s. Therefore, the department requires that each Tier A permittee develop a watershed improvement plan to determine what improvements can be made to reduce their contribution of pollutants that are causing impairments to the state's waters. The watershed improvement plan will be split into 3 phases with separate due dates. The watershed improvement plan shall be updated when necessary based on the biennial review of revisions to the impairments of the permittee water bodies based on the department's integrated report and newly adopted TMDLs. Now, for stormwater assistance grants. The department offered a Notice of Funding Availability, NOFA, to assist municipalities in upgrading their MS4 stormwater programs to comply with the requirements of the 2023 Tier A MS4 permit renewal. The department has made $75,000 in aid available to former Tier B permittees to meet the compliance standards of the newly issued Tier A renewal permit. Eligible applicants had to complete and submit the application form to receive the initial $25,000 disbursement of grant funds. Applicants must submit an acceptable stormwater pollution prevention plan, as PPP, to receive the final $50,000 disbursement of grant funds. The department has made $25,000 in aid available to original Tier A permittees for the development, update, and maintenance of an MS4 infrastructure map delineating the location of stormwater features owned or operated by the permittee. Eligible applicants had to complete and submit the application form to receive the initial $15,000 disbursement of grant funds. Applicants must then submit an acceptable MS4 infrastructure map to receive the final $10,000 disbursement of grant funds. The application deadline was June 30th, 2024. The second disbursements are contingent upon the completion of those permit requirements and the deadlines for those contained within the permit. In March 2019, the Stormwater Utilities Law, officially known as Clean Stormwater and Flood Reduction Act, was signed into law. This act authorized local and county governments and certain other entities the ability to create stormwater utilities. These allow for fees to be collected to be used for stormwater-related activities. Depending on the more unique circumstances in each community, the process to establish a stormwater utility may take up to 5 years or more. There's a lot of information on our website that outlines the steps for establishing a stormwater utility and has many resources on how to do a feasibility study and creating a fee structure. Please reach out to your case manager with questions about stormwater utilities. Here is a list of the general categories for which the stormwater utilities fees could be used as a source of funds. Please refer to the Stormwater Utility website for more specifics on each category. Wood waste recycling and leaf composting are federally regulated industrial activities that require an Egypti stormwater permit. The 2018 Tier A permit only covered the temporary storage of wood waste and yard trimming materials and resulting stormwater discharges to groundwater and did not authorize discharges to surface water activity from any processing activity. Through MS4 compliance audits, we found that municipal facilities that performed these activities were not properly managing their stormwater discharge and therefore contributing pollutants to surface and groundwater. On the industrial side, the department's wood recycler's general permit, also known as the R7, expired in 2014 and a renewal was needed. So, in response, the department created the Wood Waste Recycling and Leaf Composting General Permit, or WRC for short. This general permit became effective January 1st, 2023. This new permit ensures that proper permit coverage is established for stormwater discharges from wood waste recycling activities statewide at both municipal and privately owned facilities. This permit accomplishes this through a combination of BMPs and discharge monitoring to achieve compliance. So, that wraps it up for the MS4 program overview. You can find the contact info for the MS4 unit on this slide. If you have any questions, feel free to ask in the chat or unmute yourself. If there are questions in this chat, we'll look them over and respond as necessary. Up next is Lisa Schaefer. Thanks, everyone.
Thank you, Lisa. Are there any questions at this time? Okay, well, pursuant to the adoption of the rule amendments from last year, the BMP manual chapters that have been updated to align with the rule adoption and are listed here. So we made changes to chapters 5, 6, 9.5, 11.3, both of which are for the different types of manufactured treatment devices, and chapter 12. Additionally, we have updated the FAQs to address various issues. So shown here are some screenshots from the updated BMP manual webpage. So everything that's been updated to the rule adoption has been marked in red, as you can see here, with the update effective date. All right, so if you have any questions on that, you can always reach out to us. And if you're not seeing this, please make sure to refresh your browser. Okay, so the FAQs have also been expanded to address various issues, some of which were mentioned on the earlier slides. The newest FAQs are at the bottom of the webpage, but above the blue footer. Just look for the rule adoption date in the header, okay? Obviously, if you click on a question, it will expand to show the answer. Now, our webpage, we have templates for the Municipal Stormwater Control Ordinance, of course, which we abbreviate as SCO, that can be used by a municipality. The updates to the SCO align with the rule adoption and can be downloaded in both Word or PDF formats. On the left is a screenshot from the updated web page showing all the different types of items available to download. There's, of course, a clean copy, but we also have strike-through versions to illustrate where text has been removed, with the new text also appearing in red. Lastly, there's also a simplified version, and this version cites subchapter and section numbers from the stormwater management rules instead of the full text to reduce or eliminate the need for the municipalities to revise their own ordinance when the stormwater management rules were amended or are amended. A municipality has to comply with the applicable laws and procedures for the passage and adoption of ordinances pursuant to this simplified version. Now, municipalities must have amended their municipal stormwater control ordinance within 12 months of written notification by the department of the need for modification and update. That notification was sent on July 17th of 2023, and we are well past the deadline. On the lower part of this slide is a summary of the updates made to the SCO to match the rule adoption. Right? We also updated the hyperlinks throughout the document and cleaned up its appearance. So also, we had made some updates to other pages, and we've just included this as a handy reference for you. If you can't find something, please reach out to us. So I believe that will bring us to the closing information regarding the training. Okay, so the next course offering will be in the new year, but since you are a reviewer, you are covered for 5 years. Now, you are always encouraged to download the slides for interim sessions of the training and view those videos before your certification expires. And also, don't forget to check the webpage for updated chapters to the manual and other links for rainfall data, other trainings, everything else. So as was mentioned earlier, the email with the link for the course evaluation will go out soon, and we will need a response by the close of the business or the close of business on the date that we specify in that email. All right, as we said earlier, that evaluation survey must be completed to receive either a certificate of course completion or a certificate issuing the CPC credits for the professional engineers. So if you review for an MS4 permittee, if you attended all 4 modules, if you've completed all 4 quizzes, and then are required by the permit to complete the training every 5 years, you'll have to complete this survey before we can send out that certificate or the other certificate as well. So, all right. No evaluation, no certificates, but we will send out the certificates after we receive your course evaluation. So We will continue to use the shared email account that you see at the bottom of this slide, all right, for future training announcements. So if you haven't done so, please make our account a trusted sender. We ask this because we get so many emails that are returned. Also, if you change employers or your domain name changes, anything like that, please notify us ASAP so that we can continue to keep you in the loop for future training. All right. I think we're going to keep the room open for more questions, but you can always contact us. I think we're going to run another attendance report. Chang'e, is there anything else?
Thank you, Lisa. I think that's the conclusion of our training program. We will review the submission of your quiz and the attendance data to determine whether you are eligible for the certificate of completion and also the CPC if you requested it, and also the survey you submitted. Thank you for your participation. Thank you very much.